So I'm recording this for the second time. Just realized that I wasn't recording my screen for a whole hour, but we're going to do it again. So this section here is for functions. It's on functions. Let me give you a quick overview of functions. So functions. In our CLI tool, functions are the core building block for the commands like scan, validate, and report. They encapsulate specific operations, making the tool modular, maintainable, and scalable. So we're going to go back to our code. We're going to create a new folder, name it 2, and we're going to call it functions. And then 2, we're going to create a new folder inside of here, call it 1, function as parameter. Well, let me see if that's the right one. No, so this is just a basic function. Basic function. All right, and let's do our traditional main.go, and we do package main, and we do func main. And if you don't already know, main itself is a function. That's what we call it, func main. So let's start with our first function, and it'll be called func validate, and this should be lowercase validate path. And it accept a string called path and return an error. And let's check if the path that passed in is empty. And if so, return dot error of path cannot be empty, cannot be empty. And then now we want to return nil. So if we turn the error, well, so if it is an empty, then we will return an error, which is this. But if it's not empty, well, then we just return nothing or nil. And then so now in the main, we're going to say path equals in some random name you can give it. And then we'll say if error. So we'll get the error from this validate path that it will return. We pass in the path that we just defined, or if error equals nil. One L. And then we say format.print line this time, error, and then we print out the error. Then we're going to return it. We're going to return to break out of the condition. Print line, path is valid. So CLI functions, and then we say run main.go, and what is it asking me for? Okay, no such file directory. This is the right one? No, this is not it. Basic. Oh, we need to go inside of basic. That's why. Run main.go. All right, so the path is valid, but let's say if we didn't simulate an error, path will be empty, and now we'll get this path cannot be empty. So that's how you run that. It's very simple, and if you're coming from another language, whether it's JavaScript or Python, it's the same. Now let's go to functions. So a function can have functions are flexible and support various use cases, including functions as parameters. And another one's called a variadic function and anonymous function. So next we're going to look at for a function as a parameter. So this here was just a basic function. The next one we're going to look at is called function 2, function as params. We're going to say params. And then we'll do main.go, Close this up, and then we'll say package main func main. And so now we're going to use an example of a scanner function. So we're going to create our type, and it'll be a scanner func. It's a function, accepts a file path. I don't need that file path, which is a string, and it returns that. It returns a report string and an error, which is of error type. So this is our type. So now let's make a function that aligns with that type. Run scanner, and it will accept that scanner, which is a scanner function. So it accepts a function of this type, because this is a function that accepts a string and returns a report string and an error. And so we want to have this be defined by that type. So we'll say, and it accepts a file path string. And we say report error. That's a report, right? Yeah, report error. And we want to say scanner. So we're going to use this function here, and we're going to call file path, this path here. And then if error is not nil, I mean if there is an error, we want to say format dot print line error. Then we want to break out of that. So by returning, then we want to say else print line scan report, and then the actual report name. And then here is the function that we're going to use. So this scanner function is of this type, but the actual function that we're going to use is called function secrets scanner, and we got to abide by this. So it'll be file path, which is a string, and it returns a string and an error. And say no secret found in file path, and then nil, because it's for the error. So this is the file path, which is a string, and this is the nil. All right, so we could have another one. I'm just gonna make a dummy. Let's scan secret scanner. Let's I don't know another one off the top of my head. Let's just say validate YAML. I don't know. And then secrets found. YAML is valid. It's valid. YAML is valid. I don't know. So all right. So now here we could run that secret scanner, and we pass in a secret. Pass this function in. No, my bad. We want to run this run scanner, pass in this function here, and then pass in some dummy file name, config.yaml. And if we run this, go up, function as parameter, go run main.go. No secrets found in that. And then if we want to run this next one, let's just comment this out. we'll say run scanner because they both conform to the same type. We can say validate YAML and then, some config.yaml and run that too. YAML is validating, and this is the file path. So that's pretty much it for accepting a file path. So let me run through it again. Basically, we passed the function as a parameter. This is the function here that runs it, but it accepts a function as a parameter, and this function itself is going to be the scanner, which we pass in whether it's the secret or this. So this function gets passed in along with the file path, and it uses this file path to do some logic. And that's pretty much how it works. I'm gonna kind of breeze through these because I just spent the whole hour doing it for nothing. But if I'm skipping over something by mistake, just let me know in the comment section and I'll get to it. The next one is going to be variadic function. So we're going to create a folder 3, variadic function, and we say main.go. Package main, fuck main, and then we will say create this function called func validate files, which accepts a path. And so let's read. Variadic function allows you to handle a dynamic number of inputs, which is ideal for batch processing. So basically, we can handle a dynamic number of inputs, and you will see how that works. So we have this paths, and it could be a dynamic number of strings that we don't know in the beginning, right? And so it accepts a dynamic path of strings, and it returns an error. And then we say for path in a range of paths, if error validate path. So let's create a func validate path string, turn an error if path equals empty, then we need to return an error, so we're going to say format dot error of, say path cannot be empty. Did I spell it right? Yes. Okay, and then we return nil. And so here we say validate the path. And then we pass in that path here. And then an error equals nil. Okay, so return. So if the validate path and if the error is, if it's not equals nil, so if there is an error, then we return this error, and then we say print this out, return fmt error validating, and then we say s and then w path error, and then now we return nil, and then now here we can call it, say error validate files, and we're going to pass in some random file names or file paths. One YAML files2.yaml, and these could be anything. Files3.yaml, and then we say if error, then we want to print out that error. Validating error. This should be a comma. And this should be a comma. Else dot print line, all files are valid. And then let's run this. And so basically we have these 3 files, and we're going to pass them into the validate files, which accepts an dynamic number of inputs, and we can see those. So go run main.go. All files are valid. So that's it for that. The next one is going to be anonymous functions. Anonymous functions are useful for ad hoc operations such as filtering or customizing logic in a pipeline. So let's look at an example of that. I want to make sure I was recording. All right, so for anonymous function for your NCTR, and then main.go, package main, func main. All right. So here we are going to, let's look at this. We're going to have a func process results, which accepts an array of results, an array of strings, and a filter function that has an array, that accepts an array and returns a bool. And this entire thing returns a string array. And we say filtered is an array that's empty for now. And we'll append some stuff in a minute. And we say for, and we want to get the results. And the range of results. And say if filter, and we pass in that result. And I will explain this in a minute. Just filter.append, and we pass in filter and result. And for here we return filter, return this array. And so now results is in a string. We're going to pass in pass. These could be in anything, but for this use case, I'm just make it 2 passes. And we say only passes. So we want to only get the passes. So now we say results. And we're going to pass in this as, that's fine, like that. And then now we say return if s equals pass. Now we say fmt dot print line passes, only passes. Now let's run this, and again, I'm gonna go over it in a minute. So let's come in functions, anonymous function, make sure go run main.go. So we get back to two passes. So the way this works is it uses an anonymous function. So we have an array of results. We have passes, two passes and one failure, and then this uses this function here, and we take the result. So we pass in. So again, so this function here accepts an array of strings. So we pass in this array of string, and it accepts a function. We pass in an anonymous function, and this anonymous function, as we see here, accepts a string array, and it returns a Boolean. So we pass this function in here, which aligns with this. So this here whole logic is the function that we're going to execute inside of here. And it's going to take this filter, and it is going to filter right here. Yeah. So for each value in this array, and each value in this array, we're going to filter it by the results. So the results that we pass as in is this here, this logic. If s equals pass. So we're going to pass in the result. Each value was passed, and does it this equals pass? Yes. If it does, then append it to this array here that we append it to this array. So if it passes this logic, which it will on here and here, and then we append it to this array. That's pretty much it. It's pretty simple. Just kind of look at it, run it, and then you'll get the hang of it. So that's it for the functions. The last thing I think I want to cover, or I might wait for the next video. Yeah, I think I'm gonna wait for the next video. The next video I'm gonna go over the defer. All right, that's it for this video. I hope you found it helpful. Stay tuned for the next video. Thanks. All right, so to wrap up this section or this chapter, I want to finish this chapter off with the final section, which is defer. And we're going to add a folder to, now let's go, to here. We're going to call it 5. 5, defer. Come in and create a new folder called 1, basic. And then we want to do a main.go. And then, as usual, package main, func main. So let me kind of start with what is a defer. In Go, the defer statement schedules a function call to be executed just before the surrounding function, the function which the defer is written. It returns regardless whether of how the function exits. This behavior ensures that the critical cleanup operations like closing file handles, releasing locks, or cleaning up temporary resources are always performed, even in presence of an error or unexpected conditions. For developers familiar with languages like Java, Python, or C#, defer in Go is conceptually similar to the finally block in a try-catch finally statement. Both mechanisms ensure the cleanup logic is always executed, regardless of how the code within the block or function exits. I'm going to create this a function called func scan file. It accepts a path string, and it returns an error. We have file error equals os.open. Let that import, and then we'll use the path. And then if error is nil or is not nil, then we do this. We're going to return FMT error F. I was saying error of, but I meant error F. To open files. And then we're going to have this error. So and then I think that's it for that. Then we're going to say if error process file. Let me write the process file to function. Process file. Pointer to os.file. And then it returns a error. Then format print line and processing file. And then we say file.name. And we return nil because we don't want to return any error. And then that's it for that. And so if we come here back down to this, we can use that. So now error, and then we say process file, and then we pass in that file that we have here. And then we want to do error. If not nil, file.close. And so like this is an example of how we would close a file without using the defer. It's not the best way. So like this is like the not optimal way of doing it. And then we say file.close, and I'm gonna explain it to you in a minute. Turn nil. I'm missing. Okay. And then so now in the main, we want to use that if error. And then whatever we get back from example.txt. And we need to make this file too. Error. And then so I'm going to come in here and just make a example.txt in some file. All right. This thing is in the way, that's why I can't really see. So let me kind of read this. And again, like this is the not optimal way. I'm just going to put it up there. Not optimal approach. And so what this does, of course, you can read it yourself, but we're going to try to scan a file. And to scan that file, whenever we open it, if there's an error that happens whenever we open it, whenever we're trying to open it, we're just going to return that error, right? So that's what we do. We return that error. But if we are able to open it and then an error occurs while we are processing it, then we need to close that file and then return the error. So again, so if we successfully opened it and then now we're trying to process it and then an error occurs, we need to close it and then return an error. Also, if there is no error while processing it and it processed successfully, then we also need to close that file again. Well, not again because it's the first time, but if you see there's a duplication, so if there's an error that happened while we're processing it, we need to close it and then return an error. And then if there's no error while we're processing it, we need to close it and return a nil. So this is how you would approach this if you didn't use a defer. And I'm going to show you why defers exist. So let's go run that. Go run main.go. And so processing file exists, and then let's say we don't have that file for some reason. Well, it won't even open it up, it just return error. I'm not going to be able to mimic an error occur here unless I create an error and throw it, but that's not the point of this. The point is to show you the more optimal way by using the defer. So we're going to say optimal approach. I need to rush. I need to kind of hurry up and go. And so now we're going to do the same file, say func scan file. It has a file again. She just copied that, but just to get in the use of writing this code, we're going to keep writing it out. And it returns an error. Format print line. Oh, what am I doing? So I'm doing the wrong part. So this has a file. I mean a path, which is a string, and it still returns an error. And then it's a file error os.open, and we're going to open that path. Then if error occurs while we're opening that path, then we return format error f fail to open file v error. And then now we can defer the file close. And you'll notice that we only do this once. We only got to do this once. And so now we say format print and say scanning file, and then we say path. Then we return, did I spell it wrong? No, return processing file and send in that path. No, yeah, the file. And then, no, so that's it. So we just return that. And that's pretty much it. So if you noticed here, again, if there's an error that occurred, we had to close it. And if there's no error, we had to close it. Here, we only need to defer it once, or call this once on the defer, because regardless if it fails, we're going to close it automatically by doing this defer. And if it successfully works successfully, then we still close it, because this will run last. It's like the finally block, the finally statement in the try catch block, finally block. And so now if we run this, where's my cursor? Right here. We get the same thing. Scanning file example, I think I spelled it right, and then processing example. So that shows you how it works. And just to be clear, the point of this defer is so that you can put it on something that you want to like a cleanup. If you open up a database connection or something like that, you always want to run this. It's like the finally part. So it ensures the file is closed no matter how the function exits. It improves readability by keeping the cleanup logic close to the acquisition. Now let's do the next one. And sorry for sounding like I'm kind of speeding through. I'm gonna slow down. So let's do closure. And let's do main.go. And then we say package. Did that run? Was that the right one that I ran? And let's make sure. Yeah, it's still the same thing. For whatever reason, I think I made a change and it just didn't save on there. So, what else? Package, main, font, main, same thing. And And so I'm going to show you a gotcha in this. Well, I'm just going to show you the closure in this gotcha, right? So say var count int, mean this by default will be a 0, right? And then we say defer f print f deferred value d, and then we say count, and then count is 42 t dot print line main function exiting, and then let's go up to closure and go run main.go. And as we see, it exits. And I'm gonna close on. I'm gonna come back to this the order like last. But as we see, we get the main. It exits, and then we get the value 0. And so you may be wondering like why this shows a 0 when we clearly changed. So if you're probably wondering like, okay, so if this is the last thing that runs, why didn't the count actually go to 42 if we change the value here, right? And that is because the defer statement. So the defer statement creates a closure over the local variables. The defer statement creates a closure over the local values it references. These variables are captured at the time the defer statement is executed, and their values remain unchanged even if updated later. So what that means is at the time that this is defined, or the time that this is captured, at the time this is executed, right? Well, at the time the defer statement is executed. So at the time this is executed, regardless, however I just read it, whatever, just ignore that. What it's basically saying is no matter if this is changed here, it won't matter because this value will always remain whatever it was when we defined it, because there's nothing that been updated because it's the local value. So locally here we are at 0. And then this, when we define this, it's still at 0. So whenever it runs, it's going to have the value of 0. So that is the got you, because, when you're running this, like you may be running them in your project, you try to make an update and you'll wonder. I don't think you've run into this case, but just in case. And so the way you avoid this is, let's do another one. And we say func main. And I may not explain that clearly, but you will see the point, what I'm trying to say now, of how you can avoid this. Count, and we say fmt print initial value of count, and we say d in count, and then we say defer statement captured the current value of count is 0. So we capture the value here whenever we write this defer. So at the time when we write this, that's when it's captured. So captured count int. So it's an int that we're going to pass in. fmt dot print f deferred value percent d in, am I missing something? No. Capture count, and then we pass in count. So now we can pass that value in, and then at this time the capture value will be whatever we pass in. And so now we say update count after defer. And now we say count equals 42. And then we say fmt printf updated value of count and %d in count. And then we say fmt print line this time, main function exiting. So the expected output will be this, right? So it'll be 0. That's the first thing that's happening. And then we'll see this 42. Then we'll see main exiting. And then lastly, we'll see the 0 again, because that's when it deferred. So this is the deferred value is 0. So this is what we expect, because we see this. We're going to see the 42, which is what we print here. So we print 0 here, and then we will see the 42 being updated. So we'll see updated, because this, my bad. See updated, which is this, because we updated it here. And then we'll see the main exiting, and then the last thing will be still the 0. And let's run this. Just push up. So we see initial value count. Did I not do something right? Initial value count. Read, like, look, oh, printf. Okay, that's why. Okay, there we go. I was missing the printout. So first we get the 0. And then we get to 42, because the next statement that runs after this doesn't run yet, is 0. It's 42. Then we get this, and then the final thing that we get is going to still be the 0. Because even though we pass it in, it's still at the time of the capture, which is 0, because we initialize it here. Now, just to be, whatever, it doesn't really make sense. But if let's say we name it 33, now it should be 33 before deferred value. See, here the deferred value was 0, and now again, this doesn't make sense. We would never do this, but to show you that we can, whatever the value is here, whenever this is defined, that's the value that's going to be, shown. So I want to show for that. And the last thing, and it's kind of evident in this, but I just want to wrap it up in a new folder and just put it in this new folder. And we're going to say LIFO. That means last in, first out. Package main. And then we say func main. And then we're going to say defer fmt dot print line deferred 1. I'm just gonna copy this. It's wrong command. Deferred 2. And then we want to print line fmt print line main function exiting. So the purpose of this is to show you that it like this is a LIFO. So like the first thing, so the first one that comes in is the last one that gets out, right? So the order that it should print out will be this, because the deferred is going to happen last. And then so we're going to say this will be the first thing to print. And then the last in, first out, LIFO. So the last in will be the first out. And so that means the last in should be the first out. So this is last. So we should see this, and then this, and then this, right? Go run main.go. So get it. So main, exit first, then this was the last one, and then this was the first one. So last in, first out. So that wraps it up. That concludes. Was I recording? Yeah, good. Whew, I thought I missed it out. I did that today. So that concludes this chapter. We've covered quite a bit. I hope that was pretty, simple or, easy to grasp. If there's any questions, feel free to list them in the comments below. I will try my best to read all the comments and answer any questions. Thanks for watching.